Hi, everybody. Welcome to part three, or the third case of looking at omitted variable bias in the single regression case. And as before, you should look at part one and part two, or case one and case two. We're looking at the earnings equation where earnings depend on education. We just have a single variable. Our assumption is that the error term is uncorrelated with education. That is, the expected value of the error term conditional on education is equal to zero. It's not positive, it's not negative. If it were positive or negative, we might imagine, right, loosely speaking, then the error is correlated with the education variable. The error includes our other factors, our omitted variables. And so the assumption here is that these omitted variables are not present. But of course, if they were present, if there were another factor that was correlated with education and also determined the outcome, then our estimated coefficient would be biased on average. Beta 1 hat would be not unbiased. Instead, it would be biased. So to think about that, we need to think about an omitted variable, a z variable that is correlated with the x variable, with the education variable, and that independently causes the outcome variable y. So that's our two-part test. Is there a z variable that's correlated with the x variable, and does it independently cause the y variable? Once we think of such a z variable, we can ask how, in what direction the estimated coefficient would be biased. As we've said in previous videos, there's 8 cases, 4 cases with a positive coefficient, 4 cases with the negative coefficient of our true relationship, and then various patterns of correlation. So today we're going to do another one. We're going to imagine we have an omitted variable that we're going to call an attribute of people. Some people are just dreamily intellectual. They like to watch European art movies and they read literary fiction and they're always talking about Roberto Bolaño and stuff like that. And they just like being intellectuals. So let's imagine, and again, we just have to think this is plausible. We imagine that this condition, this state of being an intellectual, is positively correlated with education. People who have this attribute stay in school longer. School, university, postgraduate work is where, if you're intellectually inclined, you find your fellow intellectual inclined people. And so we can imagine that the correlation is positive. So that's the first of our two-part tests. And the second is that people who are dreamily intellectual, maybe they earn lower earnings than other people. They're just not, they don't care that much about money. They don't care about the things money can buy. They'd rather stay home and read a book or watch an art movie or go to a museum, and you just don't need that much money to do that. So their earnings are lower, all else equal. So if this was an important omitted variable, and we might disagree, we might say, no, there's very few people like that. It's just not important enough to be an omitted variable to bias our estimated coefficient. Or we might say, oh, that's, might be 10, 20% of the population might be like that. And so we should have a measure of that in our regression, and not including a measure of that in our regression means we'll be estimating a biased coefficient of the relationship between education and earnings. So we can think about what the direction of the bias might be, and we have that three-step process, the same as in the earlier videos. We imagine a true relationship. We see what the pattern of errors would be with this unobserved attribute, this condition of being dreamily intellectual, and then we see what the estimated line would look like. So as usual, we have our first step. We imagine that there's a true positive relationship. The more education you have, the higher your earnings. We're all in agreement that that's probably the case. Then we think about the pattern of errors with this unobserved variable. And people with high levels of education are more likely to be dreamily intellectual, and that leads them to have lower earnings than their education would imply. So on average, the people with high education are more likely to be not motivated to make money, more motivated to read books, and so they have lower earnings than they would otherwise. Their errors are on average likely to be negative. Um, by contrast, right, the people with low levels of education, they are less likely to be intellectual, more likely to be motivated to, get that airplane or that yacht or the house on the hillside and the gilded furniture. And so they're likely to earn more than their low level of education would imply. So that's our pattern of observations that we'd see in the data. And then we go to estimate the regression between education and earnings, where we have the single variable case where we have an omitted variable, which is this condition of being dreamily intellectual. Our estimated line that best fits our scatter plot is going to be relatively flat relative to the true line. That is beta 1 hat. Let me switch this to not evaporate. So beta 1 hat is going to be less in this case than beta 1. Uh, and that is where it'll look like education doesn't matter that much for earnings. It'll look like education doesn't matter that much for earnings. And that's because the high education people aren't earning very much because they have another attribute. They're dreamy intellectuals that keeps them from earning to their full education sort of potential. So that's the nature of the omitted variable bias here. Now we've covered in these three videos now the sort of the positive, the simple case where the underlying regression is has a positive coefficient. A little bit more complex when the underlying regression has a negative coefficient. So I'll reserve the next video to do that.